So way back in Unit 1, so this is like the third week of school, we talked about parent functions and all the different shapes, and there were like 8 of them. We only concentrated on 6 of them, but the last 2 that were in the notes, one of them was exponential graphs, the other one was rational graphs. All right, and I showed you the shapes of them, but then I said, well, we're going to get into these later on in another unit. So one of those 2, the rational graphs, we're going to look at them now. And then the exponential graphs, we're going to look at second semester. All right, so our rational graphs, I'm going to keep it simple for you guys. These things get real complicated really fast. And so as you go higher in math, you know, if you take pre-calc or calculus or whatever later on, you'll see how the different shapes can occur and how they get real complicated. But for you guys, it's going to stay pretty simple. There's only 2 ways that these are going to occur as far as the graphing goes. So I'll just show you the 2 shapes. Okay, so these are our X and Y axis. So our shapes basically occur like this. They're 2 curves. Okay, so it's either going to occur like that. They're called branches. Okay, there's 2 of them, and it can occur like that, or it could also occur like this. All they are 2 curves or branches in diagonal quadrants of each other. So for you guys, this is the way it's going to look. One of these 2. And you're not going to really know which way it is until you start graphing. Okay. You can't just look at the equation and go, oh yeah, it's this one. All right. So here's an example of a rational graph. We have these 2 dotted lines. These are called asymptotes. There's a vertical asymptote and a horizontal asymptote. They act as boundary lines so the 2 curves don't cross each other. Because this is a function, it has to pass the vertical line test. And if these boundary lines were not there, they would cross each other, and then it wouldn't be a function. All right, so this one right here is our vertical asymptote. And then this one right here is our horizontal asymptote. So there's a vertical boundary line and a horizontal. There's only one of each, one vertical, one horizontal. As you get higher in math, like I said, they'll get more complicated. Then they'll throw 2 vertical asymptotes in there. Okay, but for you guys, you just have to deal with one. All right, so our vertical asymptote is the vertical line. Okay, it's the vertical dotted line that breaks up the graph. And it's the equation of a line. So when we write the vertical asymptote, we're going to always start it with x equals, because all vertical lines start with x equals. So what would the equation of this vertical asymptote be? X equals -2. Perfect. Okay? Because that's where it crosses the x-axis. Right here. That's right here, -2. That's the equation, x equals -2. Now, what I want you to do is look at the equation now instead of the actual graph. Look at the equation and see, where do you think -2 comes from? The excluded value. That's exactly right. So our vertical asymptote will always come from the excluded value. And again, how we get the excluded value, we set the denominator equal to 0 and solve for x. Okay, now our horizontal asymptote, that's the horizontal line. And so it's always got to start with y equals, because all horizontal lines start with y equals. So what do you think it would be for this one? Y equals 3, that's right. All right, now let's look at the equation and kind of see, where do you think the 3 is coming from? Yeah, so it's coming from the top, that numerator, the 3, in front of the x. Now, really the way you're going to get it, and we're going to talk about this in a few minutes, is you're going to take, it's the coefficients of the x's. So the coefficient in front of this x on top is 3, and the coefficient in front of this x is 1. And if you divide 3 divided by 1, you get 3. So that's really good. So this 2 right here doesn't have anything to do with the horizontal. It's only the coefficients in front of the x. All right, so we've got the vertical asymptote, we've got the horizontal asymptote. Now we also want to state the domain and the range. All right, so just like we did with all the other graphs, how we get the domain, we look at what vertical lines are going to intersect our graph as we move left to right. Okay, so if we're standing over here, we always start right over here for domain. We ask ourselves, if we draw a line right here, will that graph ever intersect it? Yeah, because this has an arrow, right? And what does arrows mean? They mean it goes forever, right? So if we're over here at negative infinity, this arrow is going to intersect. So that means that negative infinity starts the domain. Okay? Now, as we slide from left to right, we always go left to right, we can see that every vertical line is going to intersect our graph until we hit right here, until we hit the vertical asymptote. Then it doesn't hit anymore. Because what an asymptote does, it's a boundary line that breaks up the graph. The graph cannot touch it, it can't cross it ever. Okay? That means that this line right here, this graph, or this one down here will never cross. So our domain, we start with negative infinity, hits everywhere except for this spot right here. Now as soon as we pass it, it'll hit again because it's going to hit down here. Because this one right here, this arrow is going to get closer and closer to this vertical line that I just crossed over. So it'll hit as soon as I pass the vertical asymptote. And then it'll continue to hit all the way to positive. So if every vertical line intersects this graph except for where the vertical asymptote is, all we have is 2 intervals that make up the domain. So the first interval, we always start from the left side, it starts at negative infinity. And it goes to the vertical asymptote, which in this case would be negative 2. Now, because it's not going to actually hit negative 2, we have to use a parenthesis. Now we're going to use a U for union to show that there was a break in the domain. And then we're going to pick it back up as soon as we pass negative 2. All right, and then it goes to positive infinity. So the domain will always have 2 intervals, one on the left side of the vertical asymptote, one on the right side. All right, now when we do the range, it kind of works the same way. Okay, we're looking at what horizontal lines intersect our graph. Well, every horizontal line would intersect. Okay, and we start from the bottom and move up, except for the horizontal asymptote. Okay, and then as soon as we pass it, it'll hit again. So this has 2 intervals also. So the range will start at negative infinity and go up to 3, because that's where the horizontal asymptote is. Then there's a break, so union, and then we'll pick it up again as soon as we pass 3. So none of our domain or ranges will ever have any brackets. They're all going to be parentheses. So the domain is going to come from the vertical asymptote number, and the range will come from the horizontal asymptote number. All right, so let's go ahead and state the domain for each of these equations. All right, so we don't need to see the graph. We can find the domain now just from the equation. All right, so remember the domain is coming from the vertical asymptote. The vertical asymptote is coming from the excluded value. Okay, so what's the excluded value to this problem? Negative 2, right. So then our domain will be negative infinity to negative 2, and then union negative 2 to positive. Okay, so again, our excluded value is negative 2. All right, number 2. What's the excluded value? 9, right. So then it's negative infinity to 9, union 9 to positive infinity. All right, so in this chart, this is how we find any vertical asymptote and horizontal asymptote. Okay, So this is just so when you're doing problems, you can just refer back to this real quick and remind yourself how to do it. All right, so our asymptotes. We have a vertical asymptote, and it always starts with x equals. And then we have a horizontal asymptote. It always starts with y equals. All right, so to get the vertical asymptote, we can set the denominator equal to 0 and solve, or look for the excluded value. So here's an example. Y equals 4 over x minus 5. What would the vertical asymptote be? Good. So we're going to write x equals, start with x equals always. The excluded value is positive 5, so x equals 5. Okay, so we're going to always write this as the equation of a line, x equals 5. All right, so the vertical asymptote is the easy one, because we've been doing excluded values, you know, this whole unit, it's 4.1. So it should be pretty easy to get the vertical. The horizontal ones, it's a little harder because there's a couple different cases, depending on what the equation is, how it's given to you, will change how to get the vertical. All right, so again, horizontal asymptote, we always start with y equals. Now, here's our 3 different cases. Now, you only have to be responsible for 2 of the 3, and I'll highlight which one. The third case you don't have to worry about. If you were going into pre-calc and higher, they'll throw that third case in at the end. But for you guys, there's only 2 that you have to know how to do. And I'll point out what you are looking for depending on which case it is. All right, so case number 1, we have the bigger exponent in the denominator on the bottom. So there's an x with an exponent, and the bigger one is on the bottom. All right, so anytime the exponent is bigger on the bottom, the horizontal asymptote will always be y equals 0. Every single time, y equals 0. That's the only way it can be. All right, so here's 2 examples that I want you to see why the exponent is bigger in the denominator than the numerator. This one's easy to see. You have an x to the first on top, x to the second on the bottom. It's bigger on the bottom. Bigger exponents on the bottom, it's always going to be y equals 0 at your answer. This one's a little harder to see. Why is it bigger? Why is the bigger exponent on the bottom? Well, this is x to the first down here. There really is an x on top. They just don't put it in there. It's really x to the 0 power. Because x to the 0 power is really just 1, because anything to the 0 power is 1, and 1 times 4 would be 4, they don't put in x to the 0, but there really is an x to the 0 on top. And if x to the 0 is on top and x to the first is on the bottom, it's bigger on the bottom. So one thing that you guys can just memorize, anytime there's just a number on top, okay, there's no x on top, it's always going to be y equals 0 for the horizontal, every single time. Okay? So this is a problem that I would give you on a test, where it's just a number on top. This kind of a problem, I probably wouldn't give you, where there's a different exponents like this. So definitely make sure you know how to do this for just a number on top. All right, then the second case is when you have the same degree, same exponent on top and bottom. So here's just a general form right here. We take the coefficients in front, okay, because this is x to the first on top, and this is x to the first on the bottom. They're the same exponent, same height. The highest on top and the highest on the bottom are the same. So all we do is take the numbers in front of the x's and write it as a fraction and simplify. Okay, so this would just be the a and b is all we're looking for. So here's an example right here. We have an x to the first and x to the first. They're the same degree. So we take the coefficients in front. So 4 over 1 is 4. All right, so this would have a horizontal asymptote of y equals 4. It's all right, I'm on the other one. Y equals 4. Right. So again, we just take the coefficients in front of the x. This one, we have x to the first over x to the first. So we take the coefficients in front, so 4 over 6. And then simplify the fraction if you can. 4 over 6 will simplify to 2/3. So this would be y equals 2/3. Let me do the ones above it real quick again. This one's y equals 0. This one's y equals 0 for the horizontal. Yes?
So, for the first one,
Yes.
X on the bottom is not one on top, then it's 0.
Yes. Okay. So, the only one that you're going to have to know how to do is this one right here. Just a number on top, no x. And one of these two vector cases right here. Okay? Where you just have just like a number with an x next to it, or it's a binomial. So either you just have a monomial term on top, or there's a binomial. Okay? The binomial has nothing to do with it. This number, this -3, -5, has nothing to do with the horizontal asymptote. It's just those two numbers all you're looking for. Okay. All right, so again, these are the only thing you have to know how to do for this class. But in case somebody asks, what happens if the bigger exponent's on top? Well, then there isn't a horizontal asymptote at all. It doesn't exist. All right, so here's an example, x squared over x. It's bigger on top. Doesn't have one. Same with this one. This is 3 and this is 1. Doesn't have one. So basically the horizontal asymptote starts at 0, the x-axis, and then as this gets bigger than this, it goes up to positive infinity. All right, so it never stops. So there isn't. So, like I said, these are the only two that you have to know for this class. So I'll start. Okay, those two right there. Either they're the same or different. All right, so we know how to get our asymptotes, vertical and horizontal. We also want to make sure that we can get the intercepts. Okay, so again, review just for like polynomials. To get the x-intercept, we replace y with 0, solve for x. Find the y-intercept, we replace all the x's with 0, solve for y. So we just replace 0, one of the variables with 0, and solve for the one we want. All right, so let's go ahead and answer each of these questions. All right, so number 3, what would the vertical asymptote be? Okay, x equals 6. So again, make sure you write x equals, because on the test, probably take off a half a point if you don't write x equals. And if there's a whole bunch of those types of questions on the test, each one adds up. So just let you know, right? X equals. All right, horizontal asymptote would be what? Y equals 2. Good. All right, so you have an x on top, x on the bottom. So we take the coefficients in front of the x's for the horizontal. So it's 2 over 1. Over 1. The 1 and the -6 have nothing to do with the asymptotes. Horizontal asymptote. All right, domain. So domain comes from the vertical asymptote. So it's going to be -infinity to 6, union 6 to positive infinity. The range comes from the horizontal asymptote. So -infinity to 2, union 2 to positive infinity. Okay? This is why if you get the vertical or horizontal asymptote wrong, then you're going to use it in the domain and the range, which that's wrong too. Okay? So that's why the vertical and horizontal is important, because that's going to help you get the domain and range. All right, now to get the x-intercept, we're going to replace y with 0, solve for x. So I'll do it right here so you can see it. So it's 0 equals 2x plus 1 over x minus 6. So we're solving a rational equation, and so we use LCDs when we're solving. So what would the lowest common denominator be? What would the LCD be? If you say it to yourself, I can't hear it. What would cancel the denominator out? X minus 6. That's our LCD. So we multiply both sides by x minus 6. Okay, we can cross cancel. All right, now what's 0 times x minus 6? 0. That's the important part right there. Okay, It's not x minus 6. It's 0. Every time we solve for the x-intercept, okay, we're always going to multiply by the LCD, which is always this denominator. Every single time. Whatever the denominator is, that's what you're going to multiply by. This is always going to cancel. This side's always going to stay 0. So really what's happening is the top, whatever the top is, gets set equal to 0, and then solve for x. So what would this be if you solved this for x? Negative a half. Yeah, it'd be negative a half. X equals negative a half. All right, so the x-intercept is negative a half. Now to get the y-intercept, we replace all the x's with 0. So there's two x's, and so we're going to replace both of them with 0. So I'll do it right here. Y equals 2 times 0 plus 1 over 0 minus 6. All right. So what will this simplify to? Okay, good. Or negative 1/6. The negative can go on top, bottom, or off the side. It's the same thing. All right. So again, we're plugging 0 in, simplify the top. That's 1, because 2 times 0 is 0. 0 plus 1 is just order of operations. 0 plus 1 is 1. 0 minus 6 is negative 6. Okay? So 1 over negative 6 is negative 6. All right, so that's how you find the intercepts. All right, so go ahead and start on number 4. Find your vertical and horizontal asymptotes, domain and range. It'll do those pretty quick.
There's no,
I haven't gotten there yet. You're just way ahead of me. All right, what's the vertical asymptote? Okay, x equals negative 8. Horizontal? Y equals 0. Since there's no x on top, it's just a number, then it's always going to be y equals 0. All right, so then we can get our domain. Get our range. All right, now to get the x-intercept, remember f of x and y are the same thing. So if you don't like seeing, with the function notation f of x, you can just replace it with y. So y gets replaced with 0 equals 4 over x plus 8. We're going to solve this for x. So we can multiply both sides by x plus 8. So that cancels out. 0 times x plus 8 is still 0. So we get 0 equals 4. Now, because there's no x to solve, and 0 doesn't equal 4, that means there's no x-intercept when this happens. It's like no solution, but we write none. There isn't an x-intercept. And what happens, and the reason why this happens is because of the horizontal asymptote. So think of a horizontal line, a boundary line at 0. That's the x-axis. And if there's a boundary line at the x-axis, that means there can't be a point on the x-axis. All right, now the y-intercept, we replace x with 0. So y equals 8 over 0 plus 8. Oops, 4 over 0 plus 8. And what does that simplify to? 1/2. Okay, 4 over 8 is 1/2. All right, so let's turn it over. And what I want you to do is answer each of the questions, find the vertical asymptote all the way down to the range. Once you get that, we'll go ahead and start putting them on our graph, and then I'll show you actually how to do the actual graph. All right, so this is what you should have for each of those questions. Okay, now we'll go ahead and start graphing it. All right, so vertical at x equals -3. So here's our vertical boundary line, -3. Horizontal at 0, so then that's right on the x-axis. And that's why there's no x-intercept, because there's a boundary line in it. Now we do have a y-intercept of +2. So we put that on there. All right, so this is how we're going to get our graphs. So if you remember from the very beginning when we started the lesson, I showed you what your graphs are going to look like. They're two branches, two curves. They're going to be in diagonal quadrants of each other. Okay? Now, I know they have to either be here and here or here and here. Because I have a point that I know I graphed correctly, that means that there has to be a curve in this quadrant right here, because of that point is in this quadrant, which means the other curve has to be diagonal, it has to be here. Right? So I already know where my two curves are going to occur. I know they can't be here. They have to be here and here. So what I require is 2 points on each curve. Okay? So that's a total of 4 points. You already have one of them. So we just need one more in this quadrant, and then we need 2 in this quadrant. All right, so this is how you find your points. You're going to make an XY table. This is just to keep things organized for you. You're going to look at where your vertical line is. It's all based off your vertical line. Okay, the vertical asymptote, where it's crossing. So here it's crossing at -3. So what you're going to do is, from here, you need 2 points for your x's here. You need 2 points that are on the left side, okay? And you need 2 points that are on the right side. Doesn't matter what x values you pick that are on the left. It doesn't matter which x values you pick that are on the right. Okay? It's up to you. You can pick anything you want. It doesn't matter to me. If you keep the numbers smaller, it just makes the math easier. Now, so from here, I can pick -4, -5, -6, -7. It doesn't matter. As long as I pick 2 of them that are smaller than -3, or to the left of -3. Now, when I pick the numbers to the right, I already have a point here, so I don't need 0. I can't use 0 because I already have a point that's using it. That's 0, 2. I can use any other point that I want. I only need 1 that's on the right side because I already have that point. So I can pick -2, -1, +1, +2, it doesn't matter. Okay? So it's up to you which points you want to pick. You just got to show me which ones you're using. All right. So to the left of -3, I would probably just use -4 and -5. To the right of -3, I would probably try to keep it positive. So +1 would work pretty nice. It's a small number. So now I'm going to take those x values and plug them back in to the original problem for x, and then I'm going to simplify them, and then I'm going to get my y coordinates. Then I can plot those points. Okay. So it's all based off the vertical asymptote, wherever it crosses. So it's crossing at -3 right here. I need 2 numbers that are to the left of -3, 2 numbers to the right of -3. Okay? Now I only need 1 to the right because I already have a point there. I don't need 2. You can pick as many as you want, but just give me 2 points on each. All right, so I'm going to take -4, and I'm going to plug it in for x. So this is just order of operations. You can use your calculators if you want. So 6 over -1 is -6. So when -4 goes in for x, the y coordinate's -6. All right, so now I'll plug -5 in. 6 over -5 plus 3. 6 over -2, -3. So when -5 goes in, I get -3 for y. All right, and then +1, I'll plug that in for x. I'll just do it over here because I don't have any room over there. 6 over 1 plus 3. That's 6 over 4. That's 3 over 2. If you don't like improper fractions, then it's okay to change them to decimals. Decimals are easier to graph. So 3 over 2 is 1.5. you get any kind of fractions, just change them to decimals. Again, it's easier to graph a decimal than it is a fraction. All right, so I'm going to plot those 3 points. So -4, -6, right there. -5, -3. +1, +1.5. All right, so there's my points. I can see I have 2 points in this quadrant, 2 points in this quadrant. That's what I'm supposed to have. I can't have another point that's like on top of each other or across from each other. That means the math is wrong. Okay? So they have to be diagonal. If they are, then you're pretty much done now. Just take and draw your curves in the quadrants. Run them next to your asymptotes, but through your points. All right, so it looks something like this. So our curves are never going to cross or touch our asymptotes. They're boundary lines. Okay, they just run next to them forever. All right, and then let's go ahead and do number 6. Go ahead and fill out each of the questions, and then we'll graph it. All right, so what's the vertical asymptote? 0, x equals 0, good. Yes. Because you get 0 on the bottom, and you can't divide by 0. It's undefined. You put in 0 in for x. 0 here, 0 here. Here's the math, right? Plug 0 in. This is 0 plus 3 is 3 on top. This is 0 on the bottom. 3 divided by 0 is undefined. Can't divide by 0. All right?
I'm thinking the A shown on.
Oh, okay. So what happens is, just like with the horizontal, if the vertical asymptote is 0, okay, that means it's right on the y-axis. There can't be a y-intercept because there's a boundary line on the y-axis. So there can't be a y-intercept. So that's why it's not. All right. So on this one, we have an X-intercept that we can plot, -1.5. So I know I'm going to have a curve down here. The other one's going to be up here. Based off where the vertical line crosses, so 0. I need 2 points on the left, 2 points on the right. of 0. All right, so I already have one x value, 1 point. That's negative 1.5. Okay, I don't need 2 points on this side. I already have 1. The only x value I can't take is negative 1.5 because it's already used. So I could use negative 1, negative 2, negative 3, negative 4, negative 5. Anything that's to the left of 0. All right, so how about negative 1? All right, then I need 2 points that are on the right side to get the 2 points up here. So 2 x values that are bigger than 0. I could use positive 1 and positive 2. It works pretty nice. Plug those in for x and simplify it. All right, so using negative 1, that's going to be 2 times negative 1 plus 3 over negative 1. Times negative 1 is negative 2. Negative 2 plus 3 is 1 over negative 1 is negative 1. Which puts me right there. All right, plugging positive 1 in. 2 times 1 plus 3 over 1. 2 plus 3 is 5 over 1 is 5. So 1 comma 5 is right there. And then I'll use positive 2. So I'll do the work right here. 2 times 2 plus 3 over 2. That's 4 plus 3, which is 7 over 2. 7 over 2 as a decimal, just because it's easier to graph, is 3.5. So 2 comma 3.5 is right there. All right. So again, you can see both points are diagonal from each other. Supposed to be. Now I can just draw the 2 curves. One thing that I do notice on some people's tests, please don't do this. Okay, they don't curve, the curves do not curve back on themselves. They run next to the asymptotes. Okay, so make sure that you run it next to your asymptote. All right, so this is your homework. On today's homework, you're not going to do any graphing. Okay, you're not going to actually have to graph it. You're just going to find all the information. And then we'll practice more of the graphing on Monday. And then you have 2 solving problems on the bottom, which I want you to practice solving still. So it's common denominators. Solve for F. Yeah. So you should be able to finish this before you leave. Most of the other classes finish in like 10 minutes. Mhm.